Hi, thanks for coming to this API Academy workshop. My name is Francois Lascelles. I'm Distinguished Engineer at Broadcom in the Layer 7 business unit. And this presentation is about API security and general API infrastructure considerations for GraphQL. So it seems there is no turning back, and GraphQL is not going to become the next OData. GraphQL is showing up in your architectures. For us, as an API management and API infrastructure vendor, we are helping customers with their APIs, and it is becoming currently is the top asked for modern protocol by our customers. GraphQL is on top of that list currently. We are noticing that GraphQL is being chosen for new APIs at our customers, especially for private and internal APIs at the moment. But we think that's just the beginning. And we overhear customers say things like, we are standardizing on GraphQL for whatever their particular domain of API scope is. So this is something that's definitely currently going on. And the question is, how does the introduction of GraphQL affect your API infrastructure, right? So in this presentation, I'm going to go through these topics. So API infrastructure and security consideration for GraphQL, why patterns that you're using today and that were established mainly for REST APIs aren't always adapted for GraphQL. So we're going to talk about GraphQL and authentication, GraphQL and authorization, an API infrastructure loss of context that comes with the introduction of GraphQL and how to restore that context. We're going to talk about best practices around GraphQL APIs, in particular, the hot topic of whether or not you should turn off introspection in the production instance. We're going to talk about impact on rate limiting, and why a per request counting is kind of broken with GraphQL. And then finally, this is going to lead us to talk about query cost analysis and vulnerability mitigation, and in particular, 3 different approaches to query cost analysis. So let's start with the first one, GraphQL and authentication. What are the GraphQL specific authentication patterns? And really, that's what it is. It's a blank slide because there shouldn't be anything about a specific GraphQL specific about your authentication. The same way that there shouldn't be anything REST specific about your authentication. Your authentication is supposed to be decoupled from the API implementation, ideally. So things that you're already using, like OAuth and JOT tokens and MTLS. All of these things apply to the same way to GraphQL, the same way that they were using, you were using them for REST API. So that's the good news. There is really very little impact here. So now that we've got authentication out of the way, let's talk about authorization, and specifically coarse-grained authorization, which is very often something that your API infrastructure participates into, right? So what happens is you've got previously meaningful transport characteristics that lose their status. If you're used to REST APIs, you're used to the concept of the HTTP URI identifying the resource that is being acted upon, right? So that HTTP URI is something that in GraphQL becomes completely irrelevant. You've got a single endpoint with GraphQL. An HTTP verb as an action type, right? The difference between a REST API call, if it's a get or a put or a delete. For GraphQL, again, you don't have access to this information. This is not acting as that role. It doesn't have that meaningfulness in a GraphQL API. And the same thing with HTTP status, right? HTTP 200 versus HTTP 500 versus 404. GraphQL returns errors over HTTP 200. So that's yet another thing that you can't rely upon anymore. And the details of the query syntax are inside the GraphQL syntax itself. So you need additional context to differentiate between a query and a mutation. So the details of a GraphQL syntax are opaque to otherwise HTTP-aware middleware. So here's some example coarse grain authorization strategies that you might be leveraging somewhere in your architecture that are now broken as a result of introducing GraphQL APIs. So like I was saying, the HTTP method, right? So the administrator can get any, can do HTTP get, put, post, delete, but if you're not an administrator, you can only do HTTP get. That's broken with GraphQL. That logic is no longer something that you can rely upon. Another example of a coarse grain authorization that your API infrastructure might be getting involved with is doing some mapping, for example, of an OAuth scope, right? So you've got a set of scopes in your associated with your OAuth token, and when you're calling an API, there's maybe a subportion of that that URI that shouldn't be matching one of those scopes, right? So that, again, is something that's broken in GraphQL because HTTP URIs are not used. Everything's going to the same address. And the same thing with, you know, counting errors or counting failures. You may have policies around the number of errors or the number of failures. You might be paying special attention to these types of responses. And you can't rely on this anymore with GraphQL, where errors come back as 200s. And so that HTTP status is no longer relevant for that purpose. So let's peel the layers here and look at the anatomy of a GraphQL request over HTTP. Right, GraphQL requests are packaged in a JSON envelope. So it comes to the GraphQL API as an HTTP post with a JSON application JSON content type. And so here on the left side, you're seeing the GraphQL syntax. So this is a GraphQL mutation name watch out, and you're referring to some inputs and you're specifying what you want to get back. And below here, you've got a JSON structure, which contains those variables that are provided as part of the GraphQL syntax. So when you package that over HTTP, that's what it looks like. HTTP post, application JSON, and then you've got a single JSON envelope where your variables are there at the bottom. And at the top, you've got your query entry that has as one string the entire GraphQL query that I'm showing you on the left. That's how it comes over HTTP. And so the bottom part here, where you've got your variables, everything that you're doing today that uses things like JSON path and JSON schema in order to look for pattern in your API calls, you can still do these things over that variable aspect of the GraphQL query here. But the query itself, the inspection of that GraphQL syntax, that requires a GraphQL specific capability in order to interpret that, right? This is no longer JSON, and you can't just parse it like you used to do for a REST API where everything was JSON. So you're losing some context here. And in order to illustrate a potential consequence of that loss of context, I'm going to talk to you about this graph bypass attack. The idea is that by moving input data inline of GraphQL queries, any pre-existing JSON input controls can effectively be bypassed. So on the left here, you've got a GraphQL mutation that has an input at the bottom here, and you see that the variable input that's declared in the mutation. On the right side is the equivalent mutation, if you like, but instead of having that input as a variable, you just put it inline of the GraphQL mutation. So both of these syntaxes are equivalent to one another. However, by moving this input variables into the query part of the syntax, it leaves the JSON inspection domain. So it creates a gap in what you otherwise would be able to validate using your JSON schemas and things like that. So that's a problem, because now you are potentially missing some input sanitization that you otherwise could do. And that's a problem that's introduced by GraphQL. And this is not just about input sanitization. It's not necessarily about security. Loss of context definitely matters beyond security. If you put the potential vulnerability aside, the loss of context affects infrastructure in different ways. And here's the actual customer requirement that came to us recently, right? A customer says, I need to pick an endpoint to route to based on the GraphQL mutation input. So they have a department value that comes into the mutation, and that's because of the way that their application works. Those parameters are in line of the GraphQL mutation itself. And depending on which department you're reading here, you will route to different GraphQL endpoint values. This is something that for us, the layer 7 gateway, the pattern of switching between different endpoints based on something we inspect in the input is extremely common pattern. And in order for us to do that with a GraphQL pattern like this, we need a way to interpret and get more context out of the GraphQL syntax. So in order to resolve coarse grain authorization and general lack of GraphQL context, you need some additional context, right? You need to know what the action is. Is this a query, and is this a mutation? And a mutation is name by name, right? It's not like put, post, or delete. It can be any action that is relevant for your particular API. So that context is API specific. You need to be able to have rules by the types that are accessed, right? Or as a bonus, going even like a one granularity deeper and be able to set up rules based on the properties of each types being accessed. You need to identify resources, and identifying resource being acted on requires the parsing of a mutation input. And the alternative to adding this GraphQL context into your API infrastructure is to basically pass the ball to the service implementation. And that's just not acceptable in certain domains where the infrastructure needs to be responsible for securing the APIs. So here are some examples of what we're doing in the layer 7 gateway to add some context, some GraphQL context, and allow customers to build policies based on that. So we introduced the ability to parse inline input parameters using this GraphQL extract value assertion. And so you can select an expression inside the argument, parse its value, make that available to the rest of the policy context, and you can use that to branch on its value, or you can use that to have additional conditions validated against these different inputs. So it's a new primitive assertion inside the policy language that allows you to do that. And here's another one where in the layer 7 gateway, we've added the ability to do some GraphQL schema validation directly in the policy. So you can load the GraphQL schema at design time. And this is an important aspect of it. We'll talk later about best practices around whether or not introspection should be turned on for production. So when you're using this assertion, the GraphQL schema is loaded at design time using introspection to make it easy for the administrator. And then at runtime, any query and mutation that comes in can be validated against the schema that you provide here. And you can reduce or tweak the schema at the edge. The administrator here of the infrastructure can control basically the schema that is presented to the outside world and create a GraphQL facade or a subset of the API, which again is a pattern that's very common for REST APIs that people want to duplicate for the GraphQL APIs when they are crossing a boundary or the edge. So best practices, let's talk about introspection in production, because that's a question that we often get, right? Should we turn introspection off for our GraphQL API when we are moving into production? And the point is that, why would you consider turning off introspection? the idea is that some environments just don't need it. And introspection, first of all, reveals a lot of information about your APIs, and some APIs aren't public, and that information is not necessarily supposed to be public. But not just that, the introspection itself could be abused in addition to the API. So this is something extra that you need to worry about. So here's a decision tree as an example. For every graph in every environment, ask yourself the question, is introspection needed here from the perspective of the developer experience? Are the developers going to use introspection in that particular environment, or is that environment only being accessed by applications that are already baked in which there is no introspection traffic required, right? If the answer to that is no, then yeah, you should definitely turn off introspection. And if the answer is yes, we do actually need introspection here, leave it on, but you can still have controls around it. If there's, for example, authentication applicable to your GraphQL API, you can make that authentication being a requirement for the introspection to flow as part of your gateway policy. Error masking is another thing to think about. GraphQL errors are really conveniently informative. But if you turn off introspection in a given environment, you probably want to also mask this stuff, because the same reasons apply. If introspections are not going to be used, then probably the very informative error responses also are not going to be used by a developer in this particular environment. And so you probably want to reduce some of that information. So error handling, GraphQL errors come back with HTTP status 200. That's something that people are not used to. And so you need to be able to parse JSON for that error recognition. And don't get too comfortable. Security by obfuscation is just obfuscation, right? It doesn't necessarily provide additional security. And if a hacker wants to reverse engineer your GraphQL API, they'll find a way to do that. So don't get too comfortable with obfuscation. But if you don't need it in an environment, it is a wise precaution to turn it off. Now let's talk about quotas and rate limits. Your dad's rate limits is not going to cut it here. Simple rate limiting and quotas tend to count on a per request basis. Transactions per day or transaction per month or things like that, right? But unfortunately, GraphQL, or fortunately, shifts a lot of control over to the client side as per how much data a query can return. You really control how much data comes back with GraphQL, more so than with REST APIs. But on top of that, a GraphQL query can combine as many queries and mutations as you want in a single request, right? So the whole concept of transactions per second or transactions per day is not as relevant anymore. So because of that, GraphQL introduces or at least increases the need for a per transaction cost analysis from the perspective of the relationship between the API provider and the app provider or the client-side developer. GraphQL also changes things, right? You might have a relationship in which you're subscribing to an API plan. There might be monetization tiers associated to it. And so if you're going to start charging different than per request, you need to explain how that's going to work. You need to make this part of the developer experience. For example, a developer needs to be able to estimate how much a particular query would cost in order to decide whether or not that's the best query to include in their application. So let's look at different ways of doing cost analysis, right? So watch out for GraphQL bombs. GraphQL's, this is a quote from James Davis, who wrote a really good article on how to approach query cost analysis for GraphQL. James says, GraphQL's expressiveness is risky for service providers. It is very risky because you put so much control into the hands of the client-side developer and potentially the hacker, of course. So understanding the cost of an incoming GraphQL query helps protects against denial of service and general API abuse. you want to make it easy for cheap queries to flow, but you want to restrict expensive ones. And you want to be able to detect and monitor signs of abuse around the different ways that these GraphQL queries are crafted. So let's look at different types of cost analysis for your GraphQL APIs. The first one, the first category we're going to look at is really the simple, effective strategies. You know, it's very simple to start thinking in terms of how much data is being pulled instead of how many transactions are being used on your API, right? So if you choose to define the cost as how much data is pulled, as opposed to how much transactions are being used, then it really simplifies the way to address this issue. So, for example, if you had a 3-tier model where a free plan would have 1,000 API calls per day, a basic plan gives you 1 million API calls per day, and a pro plan maybe gives you 1 billion transaction calls per day. If you decide to switch to the data instead to be more to work around this GraphQL variable size problem, then your free plan maybe becomes 1 kilobyte per day, and maybe your basic plan becomes 1 megabyte per day, and your pro plan becomes 1 gigabyte per day. So this is easy, but unfortunately, it may not reflect the actual cost to you, the API provider, if some queries are much more expensive than others. But it is close enough in many cases, and it's a great starting point. Another thing that's easy and simple to look at in the API infrastructure is the nesting inside incoming queries, incoming GraphQL queries. You don't actually need a lot of GraphQL awareness to measure that. It's actually very easy to count this using a very simple JavaScript or regular expressions and things like that. And you can set hard limits. And so that's another simple and effective strategy to protect against very unusual requests that are potentially affecting your API. And of course, it's also important to monitor your APIs. And in this case, you want to maybe pay special attention and audit queries that seem to produce the highest latencies. That would be a smart thing to look for and learn from those behaviors and adapt accordingly. So beyond the simple stuff, let's talk about cost modeling, right? Because we've talked about the cost of a query according to the resulting response size, but what about the cost of a query associated with the computational costs or the latency, which are very often associated one with another. I've got some screenshots here of a GitHub API and inside their documentation. They do a good job at showing the math associated with their modeling, right? So when you are doing a cost modeling inside your API, you're estimating cost without executing it based on assigning weights throughout your GraphQL schema and coming up with a total cost that takes into considerations these different weights, the pagination, and you put all this together in a formula, and that gives you the cost, right? So this is definitely hard work, and it is a science and an art, but I do notice that there are emerging standards for expressing that as part of your API, which is great because if the infrastructure can leverage that, I think it makes it much better than everybody coming up with their own model, right? But you also have to think about the cost of applying the model to each request, right? And can you explain it to the client side, right? You've got a very simple model up here, which is easy to understand. And that's important for the client side developer, right? Or provide a really easy to use design time cost estimate service so that if your formula is not as easy to determine, I can just copy paste maybe the query I'm thinking about and get like an estimate before I'm actually charged for the query. And then the good thing with the cost modeling is that the model that you come up with can be validated against synthetic GraphQL traffic generation in order to validate the model assumptions, right? Are the weights that you assign to your APIs really what is costing you a lot from an API perspective, for example, based on how much CPU or memory is being used? And you can adjust your overestimates and underestimates by observing, what you're measuring versus what the model says, test different assumptions, and over time improve your model. And then pushing this one step further, I would talk about cost learning. So the idea is that you're measuring the latency and the resulting size for queries being transacted on. So you're not guessing it, or there's no model involved. You're actually measuring it after the fact. And that allows you to either have an allow list or a restrict list model, right? You may want to remember cheap queries, the ones that are 99% of your traffic, and put those in allow list, and assume that everything that's on that list might be costly. So you might want to shape the traffic, for example, around those, right? Or you might remember the costly ones. You might want to maintain a restricted list because most queries are cheap, but there's only a few ones that are being used that are problematic and sign of abuse, and those are the ones that end up on the restricted list. And so you could assume that a new query that you haven't seen before is not costly by default, and only remember that it was costly after the fact. So measuring after execution can still be helpful in protecting your service, even though you let those queries go through. Right? You can maintain those lists over time and apply rules over things that you've seen before. And this works especially well in systems where the same queries tend to be used frequently, like you would expect in a lot of apps that have baked-in queries that don't necessarily vary at runtime. And then just to continue this concept of cross-learning, one of the challenge is that there's almost an infinite ways to express equivalent queries. Like there was an example that we were looking at, right? So we need some sort of GraphQL query normalizing step in order to be more efficient about the queries that we're learning about here. And this introduces obviously runtime complexity. From an architecture perspective, you need to accommodate for learning over time. A lot of people are looking at this and wondering, hey, is this something that AI can help us with? And in the case of cost learning, not really, right? Because by the time you actually process this, you actually measure the cost, whereas AI is not something that tends to get used in real time. So therefore, I don't think that there's necessarily an easy AI solution here. All right, so to finish off this session on GraphQL security, I want to talk about the OWASP API security top 10 list and which are most affected by introducing GraphQL in your architecture. So number one, BOLA, broken object level architecture. I think that this is made potentially, you potentially have more risk of having a vulnerability in your API if it's GraphQL, because the object that you're acting on is potentially obfuscated deeper in a GraphQL syntax to which you don't necessarily have the context. Broken off, number two, again, there shouldn't be something GraphQL specific about your authentication, so it probably doesn't play a role here. Excessive data exposure, I think that's the same one way or another. Lack of resource and rate limit, that's potentially a problem because of that issue around the way that people typically do quotas on a per transaction today, and how GraphQL is per transaction has much more dynamic aspect to it, right? Like we talked about. So I think that one is definitely affected by the introduction of GraphQL. Broken function level authentication, number 5. To me, it's just an extension of number 1, so that the same function that you want to validate against is buried a level deeper, and therefore you might have more of an issue there. And then I think the other ones are not necessarily affected massively by GraphQL, except maybe number 8, injection. And even then, I know that this is being phased out of the next version of DOS API Security Top 10. So you definitely have things to think about here in terms of looking for vulnerabilities in your API when they're GraphQL based because of those. So for the last slide, I would conclude by saying when infrastructure fails to evolve a GraphQL awareness, the GraphQL implementation takes a greater share of the responsibility. So existing infrastructure needs to evolve, and you need to potentially introduce new specialized solution for that. The loss of context in infrastructure from transitioning to GraphQL is a fundamental problem that extends beyond security. We're going to need to fix that. And opacity in general is bad for API providers. So thank you very much for coming to this presentation.